section 10.4, and this is solving combined. Oh man, change colors. Inequalities. Solving combined inequalities. Okay, so we're going to kind of do a little exploration. Let's say I want to graph x is greater than -2. This is kind of the who is taller than Angel. Okay, x is greater than -2. We would have our -2. Would I have an open or a closed dot? Open. Shaded which direction? To the right. Okay. What if I want to graph x is less than 3? Okay, so we have our number line. We have our 3. Open or closed dot? Open. Shaded which direction? To the left. Okay. What if I want to graph x is greater than -2 and x is less than 3. Okay, this is where your highlighters are going to come in. Okay, so we're going to plot -2 and we're going to plot a 3. Let's start with this one. I want to plot this, but we're not going to shade it in because this and is going to kind of tell me what I'm exactly going to shade in. So at -2, will I have an open or a closed dot? Open. Okay, and once again, we're not going to shade with our pencil, but pick one of your colors with your highlighter. Which direction would we shade to say x is greater than -2? To the right. Okay, so go ahead and shade that on your graph. X is greater than -2. Okay, and then let's do the same thing. X is less than 3. Once again, we're not going to shade it in yet. Okay. If x is less than 3, open or closed dot? Open. And which direction would I shade? To the left. Now, if this is an and statement, which area is greater than -2 and less than 3? What one?
The space between -2 and 3.
Isn't it this part? The and, what they have in common. Does everybody see that? The area that you shaded that they have in common, that is your answer. That is how you would graph x is greater than -2 and less than 3. Because if it says and, it has to be true for both of these, right? If you want pizza and a pop, you've got to have both a pizza and a pop. If I want x is greater than -2 and x is less than 3, it has to be true for both of those. That's why we're going to use the highlighters, because you can see the overlapping. Because if it's an and statement, you're going to shade in the overlapping part, okay? Now, the difference today is if it's an and statement, they're not going to write it like this. We've already seen this, though. Instead, they're going to say -2 is less than x, which is less than 3. And they're going to write it in one statement. But look, x is greater than -2 and x is less than 3. Okay, so that's what these are going to look like today. These are called conjunctions. Okay, conjunctions are formed by the word and. And for conjunctions, we have to find the values that satisfy both inequalities. Right, and we talked about that. So to satisfy both inequalities, well, that would be the area that they overlap, the area that they have in common. Once again, that's why we're using the highlighters. Okay, does that make sense? A conjunction is formed by the word and. Sometimes you'll see the and, but a lot of times you won't actually see the and. But if you see an inequality written like this, this will always, 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 always be a conjunction. Okay? 100% of the time, this will always be a conjunction. Okay? Everybody got that? Nobody will try to say this is not a conjunction? Yes? Okay? I should make you guys promise me. Okay. Now, we have conjunctions. We also have disjunctions, which is almost the same thing, but disjunctions are formed by the word or. And for disjunctions, these ones are kind of easier to graph because for these ones, we have to find the values that satisfy either inequality. It's like if you told me you wanted pizza or a pop, if I gave you pizza or a pop, you should be happy, right? As long as you get one of them. So, disjunctions formed by the word or, and they only have to satisfy one or the other, right? Whenever we were lined up tallest to shortest, they were either taller than Luke or shorter than Angel. Okay, does that make sense? For these ones, you will see an or. You will see the word or. Okay? Every single time, you will actually see that word or written out. And we'll see some examples like that. Yes? Either. Sorry, my writing's not the best. Okay. Questions so far? Okay, so keep all this in mind. The directions today, we are going to solve and graph. Okay? So number 1, -5 is less than or equal to t, which is less than 5. Okay, first of all, I want you guys every single time just mentally think, do I have a conjunction or disjunction? Remember what I told you, what each of them looks like. Is this a conjunction or a disjunction? Conjunction, right? Because it's in one. This will always, always, always be a conjunction, okay? Every single time. So what we're going to do first is we're going to break this up into the two separate inequalities, and we're going to combine them together with the word and. So we did this the other day. This means that -5 is less than or equal to t, and you guys told me it was a conjunction, so I'm going to say and t is less than 5. And then for me, because I know it's easier, I don't like whenever the number's written first, and after judging from watching you guys do your homework yesterday, I would strongly, strongly recommend flipping this around because almost all of you graphed these wrong if the number came first. So to flip this around, I'm going to say t is greater than or equal to -5. Notice how you can double check. The pointy end is to the -5. The pointy end is to the -5. Okay, that's how you can always double check. But everything will just kind of flip. Yes?
Well, how do you know if it's flipped?
Because the number comes first.
No, the flip, the sign.
Well, we're not flipping the sign. We're just rewriting it. I'm not really changing anything. I'm just rewriting it. You know whenever you solve an equation and sometimes you end up with 3 equals x instead of x equals 3? And we can just flip it around because we can do that. It's the same thing. We can do that too, but we have to be careful because an equal sign doesn't really matter which way you write it, but these it does. Does that help? Okay, so now we need to graph these, okay? This is where your highlighters are going to come in handy, so go ahead, draw your number line. Okay, so I know I'm going to have a dot at -5, and I'm going to have a dot at 5. So we have -5 and 5. Let's start at -5. If I need to graph, once again, we're not going to graph with our pencil yet. We're going to use our highlighters. T is greater than or equal to -5. At -5, will I have an open or a closed dot? Closed dot. At 5, will I have an open or a closed dot? Open. Okay, so now I get one of your highlighters. And let's start with this one. T is greater than or equal to -5. At -5, do I need to shade to the right or to the left? To the right. And t is less than 5. At 5, do I shade to the right or to the left? Left. Okay, once you get your graph shaded, look whether you have an and or an or. Okay, so for this one, is it an and or an or? It's an and. So what area am I looking to shade? In between, the one that they have in common. If it's an and statement, you can only shade the area that they share. So you're looking for the place where your highlighters overlap. Okay, does that make sense? Okay, now the bad news is not all of them are going to be that easy, but this is the idea for today. Okay, making sense so far? Just don't lie to me. Okay, number 2. -2 is less than m plus 1, which is less than or equal to 4. M plus 1 less than or equal to 4. You guys just have to bear with it being a little slow, okay? Okay, so the first thing we're going to do, it'll catch up, I promise. First thing we're going to do is we're going to break this apart. Well, first thing we're going to do, is this a conjunction or disjunction? Conjunction, right? Because it's one big statement. And a disjunction, and we'll see, I think in the next example, disjunction, you will see the or. So if you don't see an or, it's a conjunction, okay? So this is a conjunction. So this is an and statement. So we're going to break this apart, and I'm going to say -2 is less than m plus 1, and then I'm going to say and m plus 1 is less than or equal to 4. And now this time we do have to actually do a little solving because my m is not isolated. So for that first one, how would you solve for m? Okay, subtract 1 from both sides. So I have -3 is less than m. And for my other one, how would I solve for m? Subtract 1. M is less than or equal to 3. Okay, and then once again, over here for the first one, if the variable's not first, flip it around. So I could say m is greater than -3. Okay, so now let's go ahead and graph this one. Remember, we're not going to graph using our pencil until we get our highlighter going. So I'm going to have a dot at -3, and I'm going to have a dot at 3. Go ahead and make your dots. At -3, will I have an open or a closed dot? Open. At 3, will I have an open or a closed dot? Closed. Okay, first highlighter. M is greater than -3, to the right or to the left? At -3, we're going to shade to the right. M is less than 3. At 3, shade to the right or to the left? To the left. Since it's an and statement, I'm looking for the area they have in common. So the area that I shaded with both colors. So this would be the graph for that one. Okay? Okay, still making sense? Okay, these were conjunctions. Let's look at one that maybe is not a conjunction. Okay, this one's going to say s plus 1 is less than or equal to 5, or s minus 2 is greater than 5. See, the disjunctions are really, really obvious. Why? It says or. Look, it's right there. You don't even have to look for it. It says it right there for you, right? S plus 1 is less than or equal to 5, or s minus 2 is greater than 5. So our goal here, I want to find all of the numbers that work for either the first one or the second one. Not necessarily both of them, one or the other, okay? So I still have to solve both equations. So for that first one, how would you solve for s? Okay, subtract 1 from both sides. So I have s is less than or equal to 4. Or, for my second one, how would you solve for s? Add 2. S is greater than 7. Okay, once they're both solved, go ahead and set up your number line. We're going to have a dot at 4, a dot at 7. At 4, will I have an open or a closed dot? Closed dot. At 7, open or closed? Open. Okay, once again, get out your highlighters. Okay, for the first one, s is less than or equal to 4. At 4, do I shade to the right or to the left? To the left. S is greater than 7. At 7, do I shade to the right or to the left? To the right. Okay, now I want the numbers that are less than or equal to 4 or greater than 7. So this time, which areas do I shade?
None.
Both of them. Both of them. If it's an or statement, I just want the values that work either for my green shaded area or my blue shaded area. So if you have an or statement, anything that you highlighted, you should go ahead and shade in. Because an or statement, it just has to work for this or this. It could be in any of these shaded areas. Okay, yes?
I don't know how much do you have to use our highlighters?
Yes. Yep. Okay. Any other questions so far? I only have 3 more, okay? And I'll let you try the last one on your own, okay? Okay, number 4. 2x plus 3 is less than or equal to negative 2, or 2x plus 3 is greater than or equal to 5. Okay, conjunction or disjunction? Disjunction, okay? I want you guys to take a second. I want you to solve both of these inequalities and then stop and we'll graph it together, okay? Okay, so hopefully you got x is less than or equal to negative 5/2, or we could think about that as negative 2.5, or x is greater than or equal to 1. So if we draw our number line, we're going to have a dot at negative 5/2, a dot at 1. Okay, at negative 5/2, open or close dot? Close dot. At 1, open or close dot? Close. Okay, we need our highlighters out. X is less than negative 5/2, shade to the right or to the left? To the left. And x is greater than or equal to 1, shade to the right or to the left? Right. Once you get it shaded, double check, do I have an and or an or? An or, so I'm shading anything and everything. Go crazy with your shading. If you highlighted it, it gets shaded with your pencil. An or statement, you shade everything you highlighted. An and statement, only shade what they have in common. Okay? Okay, 2 more. Okay, number 5. Negative 29 is less than or equal to 5x plus 1, which is less than or equal to 41. Okay, conjunction or disjunction? Conjunction, right? This is an and statement, okay? So first thing we're going to do with this one is we're going to break this apart into its 2 separate statements, okay? So we have negative 29 is less than or equal to 5x plus 1. And then the second one, we have 5x plus 1 is less than or equal to 41. Okay, I want you guys to go through, once again, solve both of these, and then stop. We'll check our answers together. Okay, hopefully we got x is greater than or equal to negative 6, and x is less than or equal to 8. Okay, so this time when we're ready to graph, we'll have a dot at negative 6, a dot at 8. We'll have an open or closed dot at negative 6. Closed dot or open dot at 8. Closed, both places. Very good, very good. Okay, this time with our highlighter, x is greater than or equal to negative 6. At negative 6, do I shade to the right or to the left? To the right. And x is less than or equal to 8. At 8, do I shade to the right or to the left? To the left. Now, always double check. Do I have an and or an or? And, if I have an and statement, what area do I shade? What they have in common, right? So I'm going to shade where I see both blue and green. So I'm going to shade in the middle. Okay? You guys ready to try one on your own? Yes. Okay. Last one here. Negative 3 is less than or equal to x minus 2, which is less than 4. When you solve both of your inequalities, should have ended up with x is greater than or equal to negative 1, and x is less than 6. So you should have a closed dot and an open dot, right? Shaded to the right, shaded to the left, and then we're shaded in between, okay? Anybody not get that, not know why? All right.